In the notes, there were two formulas you're supposed to know. This is way back from the very beginning. This one we used a lot. This one not so much, but guess what? Today I'm using it. So this one right here, this limit goes to 0. And since that goes to 0, 0 times sine x, that's just 0. And so your answer is cosine x. So derivative of sine is cosine. If you were to do cosine, derivative of cosine, instead, the only difference would be, this would be what? Cosine x? But then your formula changes, because there's a different formula for cosine in here. And somehow you would do the same sort of thing, and at the end you would get negative sine x out. I won't do that, but.
So, say you pop some of those on the test.
I'm not going to ask you to prove any of these formulas.
But would you accept it if we just knew?
If you knew what?
That it was like, that one was different.
Oh, you need to know that. Yes, I expect that you know the derivative of sine is cosine.
Oh, okay.
Yeah, I want that to just pop off the top of your head. The reason I showed you these two proofs is because I just don't want these formulas to seem like they just came from nowhere. Like, someone did the limits the way they were supposed to and got an answer. All right, we just don't have time to prove all of them. All right? Okay, it's 2 after. We still have a lot of time. Just want to make sure I've covered everything I want to here. One more. 2 more, sorry. How about this? Let's say f of x is equal to square root of x plus cube root of x. I ask you to find f double prime of x. F double prime. The derivative twice. What would you do first? Rewrite them as powers, right? X to the half plus x to the 1/3. And then do your derivative once, and then do it a second time. Go ahead, I'll give you a few minutes.
Derivatives of one is the parentheses and one out there, right?
The what?
No.
The derivative, you're just going to do the power rule on each of these, like we do, and then do it a second time.
Just make sure.
Yeah. Just give me a quick little show of hands. If you get this, just raise your hand so I can see like how long it's taking people. So you're good? If you're hung up on something, just raise your hand. I'll come by and kind of wave me down. I'll help you out. Fractions, yeah. It's not really the calculus, right? It's the fractions that
It's so
mess with
simple,
you.
That's the thing too. You're like, what the heck?
Yeah. But you can see now why back in college algebra we wanted you to get comfortable with the idea of going to this notation instead of sticking in this notation, because it's easier to work with when you're doing derivatives.
Yeah, I get it now.
Man, those rules are cool.
Yeah, they're nice, aren't they? All right, is that sufficient time, you think, for everyone? Close? All right. So what if you had a question like this? I don't want to do the one that's right out of the book. Let me see if we can handle this one. I'll change it up a little bit. Where is y equals, or where does y equals x minus 2 cosine x have horizontal tangents? So I'm going to graph this real quick so we can just take a look at what this graph is. It was x minus 2 cosine x. Is that correct? Go back in here. Oh, crap. So I was zoomed in there, and you could see, when I say horizontal tangents, what I mean is where do you have flat tangent lines, right? Flat here, flat here. It looks like we only had 2 answers, and then I zoomed out. And when I zoomed out, we realized that there are infinitely many places where that happens. Now, this is kind of like it. Notice, do you see it as a cosine function, though? Do you see that's how they use the cosine function to do that thing? But no, this one, unfortunately, is not. But we want to find every one of these points where we're going to have these flat tangents. Do you understand the scope of the problem? Okay. We should have an infinite number of answers. And we should have a way of saying where they are. All right, so horizontal tangent means you really want to know where's the derivative 0, right? The derivative is the slope of the tangent line. This is saying, tell me where the slope of the tangent line is 0. So you have to take the derivative. Let's take the derivative. All right, well, we have 2 terms, so I can do them individually. The derivative of x is 1. Now, negative 2 is attached to a function, so it's just going to come along for the ride. Negative 2 times, now what is the derivative of cosine x? Negative sine x. So it's going to be times the negative sine x, right? And when you put those 2 negatives together, you get plus. So my derivative is 1 plus 2 sine x. Do you agree?
Yes.
Now I'm setting that equal to 0. And this, being set equal to 0, leads you back to pre-cal. This is part of one of the main goals of pre-calculus, which is to be able to solve a trigonometric equation. This is why, because it's going to allow us to find where we have horizontal tangent lines. So let's try and solve this. And everybody's going to do this a little different, depending on who taught you this. And I'm just going to do it the way that I show my students to do it. So let's just see if our ideas match up at all. I'm going to solve it almost like a linear equation. I'm going to move the 1 to the other side. So far we're on the same page? Yeah. Divide by 2. We okay with that? Divide both sides by 2. Now this is where we're going to get some variation. And this is where I'm going to see if you really learned what you were supposed to learn in pre-cal. How do you solve that? How do you solve for x here? So anyone want to be brave and tell me? Go to the unit circle. How many of you are going to go to the unit circle? Show of hands. Unit circle? That is very promising. How many of you are going to go to the graph? Anyone going to go to the graph? It's okay. You can raise your hand. Okay. Good. Unit circle. Very, very happy to hear that. So you can go to the unit circle. All right. Continue. There's your unit circle. You're going to do what?
Well, it's in quadrant 3 and 4. Where you get
What's in quadrant 3 or 4?
sine x equals negative.
The what value? What?
Y value.
Okay, so you're looking at the unit circle and you're looking at the y coordinate. Why the y coordinate? Because it's sine. If it was cosine, you look at the x coordinate. So you go along the unit circle, you're going to look at the y coordinate, you're going to look for 1/2, negative 1/2. And that's going to be happening like here and here. So what are these angles? This is 7 pi over 6 and the other one is 11 pi over 6. Agreed. Everyone got that? Yeah. That's 2 answers. There's supposed to be an infinite number of them. So how do we get all the answers? What you have to do, because right now I agree with you. Right now I totally agree that if x is equal to 7 pi over 6, or if x is equal to 11 pi over 6.
So is it just double those?
Kind of, yes. If you plug in those 2 values, we should get this 0. That means that's where we should have a horizontal tangent line. Agreed. But you can have this angle, and remember we have 2 angles are equivalent if they're coterminal. So I could start here and I could go out to 11 pi or 7 pi over 6 and be here. But I could have started here, gone all the way around once, and then added another 7 pi over 6 and been at the same place. So I could be this direction plus any 2 pi multiple would get me back to that. So what I'm going to do here is x plus any full rotation. 2 pi is a full rotation. 2 pi k, some instructors use 2 pi n. Depends on your instructor. How many remember seeing 2 pi k? 2 pi n? It doesn't matter. It's understood that k is an integer. So here, same thing. You could be here or any full rotation back. So 2 pi k. There you go.
Weren't we always supposed to like set it
What's
up
wrong?
like that?
No, like she never taught us how to do. Like I knew that from the textbook, but like, she never really taught us how
Okay.
to do the K, whatever. But I was just looking at your old notes.
Okay, yeah, I can't speak to that. I'm sorry. Sorry you didn't see that. You should have. Does it make sense?
Yeah. It does.
Okay. So that's it. If I go to my graph right now, I'm going to go out on the limb and I'm going to make sure I'm going to see if I got it right. I'm going to go ahead and just say, what if k was 1? We'd have 7 pi over 6 plus 2 pi. If I add those 2 together, I would get a common denominator. Make this 6 and make this 12. Is that still the same? And then add that up, that'd be what, 19 pi over 6? I'm going to go to my graph and I'm going to have it plot the point at 19 pi over 6. And it better be a flat horizontal tangent line there, or else we messed up. What is, someone on their calculator tell me what, well no, I don't need it, never mind. Point, oops. What was it, 19 pi over 6. I need to find the point. Okay, there it is. Right there. Does that look like if I go straight up, I'm going to be up there? Okay, well, I can do one better. I can have this program tell me where the tangents are. Wait a minute. extremes. Next. Can you see that little X on there? It's finding them for me. There it is. Okay, the X coordinate of that extreme value is 9.94838, which is probably 19 pi over 6. Did someone try 19 pi over 6 on their calculator?
Yeah.
Was it 9 point what? 94 something? Yeah, okay. So that's it. See what we've done? We've got all the answers. Yes.
So if you get a problem like that, how would we know that it does more than one iteration?
That it does more than one.
So that there'd be more answers than just
Like, how would you know it's infinite answers?
Because the equation itself was a trigonometric equation and it was not confined to any interval.
so then you have to.
So you have to find all general solutions. So back in pre-cal, if you were asked to solve this equation in pre-cal, I forgot what it was, 2 sine x. If you're asked to solve that in pre-cal, if you're not given an interval where to look, then you have to find all solutions. So you need to know that you're going to have an infinite number just from this.
That's where the plus 2 pi.
That's right. That's where now if they say just find the solutions between 0 and 2 pi, then there's only going to be 2 of them. Because you can see them, they're right here. Here's 0, right? You start rotating through 2 pi. There's one answer, and then there's the other, and then once you get to there, you stop looking. I don't think the book gives you an interval to look at. All right, I think that's enough time on this. Oh, I wanted to show you one more, but it's in the homework, so you can check it out. The question is, in the homework, it's to find the notation they use. Where is it? D99 over D99x of sine x, which means find the 99th derivative of sine. Which means you could take the derivative once and get cosine. Take derivative again, get negative sine, and then take derivative of that again, and again and again. It's going to oscillate, and I encourage you, I did that in the homework video, I encourage you to watch that because there's an interesting thing I talk about in that problem called modular arithmetic, and it's very helpful in a problem like this, so you don't have to actually go out and take 99 derivatives. You recognize a pattern, and then you're able to get an answer even if I change this to 9,900, or even, let's say, 99,937. You would be able to find the answer pretty quickly. But I want to leave some time to talk about the test. So you ready? Make sure you do your homework. Make sure you watch the video for next class. So the video for next class is 2.4. It's very short. Very short. A few minutes, probably. Always be ready for a quiz. Yeah. All right, so I'm going to hand your test back. I'll call your name. These are in no order, I don't believe, but I'll mix them up just in case they were in some sort of order. Okay. Well, I mean, like if I was handing them back like lowest to highest or highest to lowest, then then you would know like who did.
I think the last one is mine.
Just trying to be honest, or not honest, be anonymous as possible. All right, Leah Sanchez. Please don't go anywhere because I do want to talk about these. Abraham. Juan Rodriguez. Christian Deng. Timmy. Izzy. Alan, I think. Alan. Rena.
Yes.
Okay. Nareda. Did I say that right? Okay. Isaiah.
Which one?
Rodriguez.
Here.
Okay. Amanda Sandoval. Fred Martinez. And you know what? I can stop recording also.